Alright, so today we are going to be learning about creating a PCB in KiCAD. So, first step, create a new project. We can have this in our desktop folder. KiCAD will create a folder for it. So we can say this is going to be our DP converter driver. It's going to be the name of the board. Now we can open the schematic editor. That opens up. Resize that a bit first. Alright. Now here we have our schematic editor. We can place in components. Problem is, main component here, it's a DisplayPort redriver. We don't have the component for it yet, which means KiCAD doesn't know what the schematic symbol looks like or what the footprint looks like. So our first step is going to be, we are going to be creating the schematic symbol and footprint for this part. See, just like I said, DisplayPort redriver. So it takes in DisplayPort video signals and amplifies them and then redrives them out the end. So one of these rows is for input pins, one of these rows is for output pins. So it amplifies the signal and allows you to create longer cable setups without a lot of signal degradation. So first thing we do, we download the datasheet. It comes up here. We wait a bit. There we go. Whole datasheet right here. So for the footprint, we're going to be looking at We're going to be looking at the footprint part of the datasheet, and we can pull up the footprint editor. First, though, we want to look at the schematic. So we're going to pull out the create, delete, and edit symbols. I have a custom parts library I have created. So these libraries hold parts. I can create a new part in the custom parts library that is this part. So I can copy this, go in here, paste it in here. Default reference designator U is good. U is usually ICs or like chips. Alright, leave these options as default for most cases, they're fine. Alright, here we have it. Now we can go ahead and Control S to save. That saves our empty schematic symbol. Now let's get to work. So we pull this up here somewhere. We can place a rectangle. That will be the main body of the part. We can edit this. I like to have my rectangle look different on the inside, so we can fill with body background color, like this. Now our part kind of looks like something. Alright, we can do our best to sort of center this. If you zoom in enough, you can see a grid. It's pretty faint, but it's there. So we can go in here, push this to exactly this size. Now we go 1, 2, 3, 4 units square over. We can go like that and match it out sort of to these more exaggerated square lines here. Now we can do the same thing here. I'm going to go 2 down, then 2 down from the center to like that. Alright, there's our square. Now let's take a look at the datasheet and figure out what all we're going to have to do. So go over here, pull up the datasheet, and we're looking for, here's the package pinout. Let's keep looking. Yeah, the package pinout is what we're looking for. So we're going to want look at the pin configuration. Now let's look. Many chips, such as this one, have multiple different packages. So there's a form factor here. There's a bigger form factor here. Which one do we have? We have the PI3DPX1203BZLEX versus BZL. We can see this is a BZL, so it's going to be the smaller of the two. You see the BZL has like maybe 12-ish. Yeah. Okay, this looks right. So it's going to be the BZL that we're going to be copying. So we go over here, we get this on one side, this on the other side, and let's start placing pins. So you go place, add pin. But you don't want to click through the menu, so you can just press the P key. Press the P button, pin name. Just going through the list. 1, A0RX plus. Alright, A0RX plus. next one, you can just click again, A0RX minus. Right? Like that, and then so on and so forth. VDD. There are properties like input, power, output, that kind of thing. You can ignore those. It'll help in certain situations, such as if you're doing simulations with a chip or something, but in general, you don't really have to have those. If you're doing something quickly, that's something you can just sort of skip over. So we just keep going through the whole list. Oh, something happened here. If we put two over them, if we have two pins over, we can just click one of them, drag down, and then we're good to go again. Yep, A2RX, and then we keep going. Right. A3RX plus and minus. Alright. We can see the A3RX, these plus and minuses are because this is DisplayPort. DisplayPort uses differential signaling. One wire is a positive and one wire is a negative. So it's the difference between the two currents that actually carries the signal. So you have 0, 1, 2, and 3 are the three different differential pairs. The plus and the minus, or the plus and minus of the differential pair, they go into those input pins. We'll see more about that later when we route. Alright, keep going. Now, we can make this a little smaller. This can be a little too big. Right? Now keep adding pins. SDA and SCL are our I2C pins. So therefore, configuring the chip, telling it how we want it to operate, that kind of thing. Let's see, PRS in T pound. Probably some kind of a present signal, so maybe it would detect if DisplayPort is connected. I'm not exactly sure. I2C. That, I believe, enables I2C. We're going to go no connect. No connect. And this electrical type being no connect, we should have this be unconnected, because it will make an actual difference. See, we can't connect a wire to that. It's got the X over it. So you should include that. Alright, now we keep going. Place A3TX minus. Oh, it is still unconnected. Something to keep in mind, the electrical type, it's carried. We can put this as outputs. This is an output. The electrical type is the same as the last pin you did. So you need to be careful what kind of thing you're using. A3TX plus. And we just go up the line here, VDD. And if you're getting tired of this, we can copy and paste and then do the modifications. So A2TX, VDD, this little block is the same. For the next one, just instead of A2, we need A1. You can use, press E to edit, and then use the arrow keys. And then switch that out. Now let's do it again. Here we go, VDD, and now this. A2 becomes A0. And this A2 becomes A0. Alright, now for the pins at the top, we can go ahead and, this is FG0. Next one, FG1 slash I2C reset pound. Next, EQ1 AD1. forgot something. I forgot all of the pin numbers. We're going to have to add those in now. Input. This is 1. Let's see. 1. I should have been doing this all along. Skip forward a bit. And we're back. I have just numbered all the pins. Now, I don't like this shape. This shape needs to be a lot narrower. So I'm going to select these. You can click and drag. Now I'm going to select this. I'm going to pull this back maybe this much. Now I can select these, pull them in. This isn't necessary for functionality, but it makes it look prettier. I could even pull it in more. Probably like this. And then probably like this. Even more. Alright. And here we are. Like that. Now we Control S to save again. This is good. Now we've created our symbol. Now we can spawn in our symbol in our schematic. Go over here, back to the schematic editor. Alright, we press the A button. That adds an instance of a footprint. That adds an instance of a schematic symbol. It can take a while the first time you start up to load everything. That's normal. Don't worry. Alright, now, let's see, what was the name we just did? It's a PI3, so PI3. Here we go. Pull goes, comes up, custom parts, PI3DPX1203BZLEX. Press enter. Here is our part. Alright. That's our first step. We've now created a schematic symbol, and we've put it into our schematic.